Hello wonderful developers. This tutorial we're gonna talk about NFTs. Basically, apparently on Google Trends, NFTs they have surpassed in interest crypto. So strap yourself in because we're gonna learn how to create, sell, mint, everything about NFTs. Let's go! Oh, and before we continue with the tutorial, please don't forget to like, subscribe, and ring the bell for notification. It definitely helps me keep motivated, and also I don't create content on a regular basis, and it will be also easier for you to get notified when new content is out. Let's go. So first the setup. To the left we have our current contract that we created a smart contract from scratch, and to the right I have my research that we will use in this tutorial. My plan is to copy code from the right and add it to the left, but to do it in such a way that all the code that we're gonna go through, it becomes digestible, so you don't end up at the end of the tutorial with a bunch of code that is you're gonna spend too much time trying to figure out what it does. There's going to be a considerable amount of things that we're going to add, and this is why I'm doing the tutorial this way, just to be able to go relatively fast and end up with a digestible code that it was created literally from scratch, and it can mint and sell NFTs. The actual contract right now, it's pretty empty in the my contract file, and we're going to do the same to the current one. We don't need to code for this. We can just work our way through. Okay, so let's see what happens now if we remove this. The storage and the initialization, we basically do nothing. We just deploy our bytes to the blockchain. And the camera was built, and now for the test we're going to have some errors because we just removed that storage, and we can come here and from our state at the end we can just remove this because it's not added to the storage anymore. I guess we can test like this. Alright, so we have the test. Next thing, let's create our NFT module. File NFT module, and let's just try to make this one as simple as possible. As always, make it a trade NFT module. It's gonna be empty. Let's just try to see if this one's gonna compile. This. Okay, that's not bad. Actually, this is not used. Actually, is pointing out by the IDE. Let's import it or use it in our contract. Basically, we specify this as mod NFT module, and now let's see. What is happening here? Still compiles fine, and we use it in our contract. So NFT module. All right, let's see what is happening now. We have errors. Let's go to the first one. No endpoints in NFT module. Okay, so the NFT module also needs the imports from the from the Elrond library. Let's just take them. Alright, that's Elrond, tapping code. Probably can get away without tapping code at the moment. I don't want to make this tutorial longer than it needed, so I'm grabbing most of it that I need, and also this one is an Elrond think that's it. Let's see how it goes around. Cargo. So it does compile. It's just one warning is tapping code apparently is on by default. Oh, you know what? That's it, right? No more errors. So continue that. And see how Alpine what has to say about it. So well, will it? Yep. All right. So also Alpine is happy with this. We use it. This is useful interaction log also. Directory. And the only reason why I have this is just to have a tutorial, so you don't need to create it in case you clone this. Nothing else but a pointer, and let's see what our status is. Yeah. So this one live net snippets. It's going to be a shell script. Okay, so we do have a file in interactions. This one we need to force add it, and also the alice spam, because this is ignored by git ignore, and also this one is ignored by git ignore. Let's go inside. Interaction logs, and we need to add this file. We need to force it. So now we do have the the empty file, and also we need the alice wallet. Let's users. So you can add your own file, except I'm not going to add my file, Alice. Sorry. So new file. Yeah, I didn't force the Alice. Okay, Alice and also interaction. So now we can add them all. So we do have the empty file. That is just a pointer, so the folder exists. The snippets, which is still an empty file, and also we added the alice spam. Good to go. Sorry, I did this. So how do we deploy this? Well, let's divert our attention to the snippets, and this is the deploy method. Just add it here, and what it does is using RPI to deploy, and then RPI creates a set of files for it that it can parse. It's in the well, yeah, we're actually gonna place it in the logs, and it's gonna extract the address from there, and then it's gonna set it into the RPI data store, the tool itself, so it can be used later on by the previous calls. Now this method uses a couple of parameters, but the only thing that we need for this to work, it's this variables here at the top, and well, hopefully that's the only thing that we need. And let's see. Okay, so we need to load this so let's see now. How are we standing? The contract still builds, and we need to load this file and call the deploy method now. Deploy and see what is happening there. That's a lot of things bad. Yes, I forgot about the deploy gas variable. Let's also copy them. It's the just some values that we will need. This one is used here. So let's load it back and see if we can deploy. All right, so we're able to deploy. This is the smart contract address. You can also check the transaction too much right provided. It's basically our code is too small, but it still got deployed. And this is the input data. It's basically our contract. Right now it's just empty. That's our contract is very small. If we do go to the contract address, this one, so here on Explorer, let's locate, we will see that the code is attached to the contract, and that's it. So we can now that we have deployed an empty contract, it's time to put some content to it. First thing, we're gonna get the tests. So let's say this one, create an NFT scenario. Just gonna copy this scenario into our code in mandos. And by the way, I think the init scenario needs to be renamed, because this one is using the previous scenario, but I used a different name in my research, so I'm just gonna rename this one. As the actual one reference. So yeah, refactor. And that is basically it. Now the and this one, of course, is going to fail. Just want to make sure that it builds here. All right, so it does build, and now our tests, as you can see, they do fail. So the function here, hopefully most of the time you're lucky, and the errors that the mandos report are pretty indicative. In this case, it's very clear what we need to do. We need to add a create NFT function function not found. So we need to add a method that creates NFT. So if we do look in our test, it sets the previous setup, the timestamp, and now we do have our contract. That we're gonna worry about this later, but actually in this case the contract has the ESDT role NFT create, and I've heard in my research that at the moment you cannot test using mandos giving the actual role, so you need to set it and then test later on the following functions. And in the actual contract, is my contract, and is actually trying to access this method create NFT, and from here this error comes in, which the argument we're gonna go about later. But basically this is like the name, that's the royalties, the actual string that you're gonna assign to your NFT, and this is the price, and there's some the gas limit and the gas price. And what comes out to the specs that it actually creates the NFT. This is the how many NFTs are there and the nouns of the NFT, and nothing else really matter. And then of course the contract creates a couple of them, and the second one, and a third one that assigns a price using a different token, not Elrond. So this is an example how you can use a different token as payment. And of course in the check state and so on. So this is a very extensive test, and I'm not going to go into details. Like the focus of this tutorial is to get you up and running to write your own contract, and just cloning a project will not do. You need to copy pieces of code and understand why that piece is in your project, because if you just clone a specific project without going through the effort of like analyzing each line of code, you're gonna find yourself like blocked too deep into a problem, and you're gonna find yourself that you need to step way back, and there's no way that you can estimate how long will it take for you to figure out an issue, right? So now let's continue our I'm digesting, so I'm digressing, and that's not fun, I guess. All right, so we do have a test that fails. Let's just copy into our contract right now the actual part that creates an NFT. So this one, create NFT. This code relies on a bunch of other things, but we're just gonna look at the errors that the compiler spits out, and we're just gonna copy the pieces that make sense. So we're gonna try to speed this up as much as possible. So we're gonna minimize this to get the entire method on screen here. So this is the create NFT method. It has a bunch of arguments and so on. So after adding this one here, let's just see what our compiler says. I'm going to use cargo in this case because I like the coloring, and it's I found a trick when you copy code in Elrond. Just open a new shell, because the errors are so many. It's fine. It's getting harder to find the first one, but with a new shell, definitely, or it's easier. So cargo build, and we're just gonna land on the first error that this import does, and we're going let's go, how do I go top? I don't know. Okay, so what this one says, example attributes. So we need to copy the example attributes where this one is used. Somewhere, I guess we can look for. Oh, so this is creates the attributes, is basically the creation timestamp. That's our attributes. So let attributes, example attributes. So we need the attributes. Also, we will need the price tag. Basically, the price tag is the token identifier, the nouns, and the actual price. So I'm gonna copy both of them, and I know for a fact I'm gonna, but okay, let's just take these two. They're pretty obvious, so you're not gonna want to watch me seeing all the errors. Okay, so we have these two things, and let's see now. Cargo build, I guess. One more time. I said this is easier. Well, this is pretty straightforward. Create NFT with attributes found for reference self. Okay. So create NFT with attributes. This method does, we don't have it, so we need to copy also this method. Create NFT with attributes. So the actual create NFT calls this one. It's another pretty long method. I'll just see. So after it does the checks, is basically it checks the token issued payment and sets the attributes, and then calls this one. And let's just see now what other errors we have. Well, I know for a fact that we're gonna get the top encoder, so we'll just get the use here at the top. Alright, and look for our error again. Sorry. Cargo build. And now what else? Price tag. Yeah, we also need to import the price tag. That's the storage, and we're also gonna need the token ID. I'm just gonna copy it now. This our storage is using two of them, the token ID and the price tag. So let's take both of them and add them here. And I found out that it works best if you just set the storage at the end. And all right, cargo build. They still require local roles set. Also, yeah, this one is used basically. Let's just see. This is way easier to find out. What is it? It's by attributes. It's right at the beginning. So require token issued and require local role set. How come this one? Because also that one needs to. We need to import. So require local roles. Or maybe I didn't align it on the first error. Probably yeah. I need to exit. Open a new one. So yeah, royalties, NFT amount, and then required token issued, which is correct. So let's just get these values. The royalties and NFT amount. Just put it at the top, right here, and also the required token issues, and they're also basically this one checks that actually the token. The collection for this NFT was created, and the second one that the current smart contract has the role of like NFT create. If you remember in our test, the test already sets these values, but we will need them in order to actually get this create NFT method to compile. So I'm just gonna add this one here at the end, and let's see what else. Sorry. So let's see. So let's see what else we need in order for this to compile. Sorry. No, not like this. Cargo. Build. All right, so it does compile now. I'm just gonna clean it and let RPy do compile also. Sorry, cargo clean. something's wrong here. Okay. So AirPy managed to compile. Let's see if that test works now. Test. And the test succeeded. Let's play a little bit with the test, because tests that just passed are no fun at all. So deploy testnet interactions. Oh, sorry. Create NFT test, and I don't know. We're just gonna say the first token is what else to remove from here? Okay. This basically, okay, let's just play with this one. It's using a different token as a payment. Contract test, and it's gonna say this is what we have, this is what you expected, that's the 7 at the end, and basically this is what we have. If you take this and convert it back into decimal, then you're gonna understand this is the hex form of the text. Right, fixing it back. Good. And that's it. Basically, we tested creation of the NFT. Let's just do a commit. We managed to create an NFT, but in order to be able to do the same thing on the DevNet, we need 2 extra things. One is we need to handle, there are 2 limitations of the mandos infrastructure right now. So you cannot handle the call of issuing token. You can only set tokens, and you cannot handle the process of like giving roles. You can only set roles. So this is why if we go into our create NFT in the state, we have the role already there, and also the storage it adds like a different like NFTs, and the user that actually buys an NFT using semi-fungible token. Sorry. So here on the create NFT, it says this one you can buy it with this token, and whoever buys that token, this contract, well, actually this one is never bought, it's just created, because we're working on the creating the NFTs, and that's it. Now, so how do we go around about this? In mandos you can only set them, but in real life you need methods for issuing the token and also giving permissions. So the first one would be issue token. Let's copy this one in. This is the method of like issuing the token. NFT module right at the end makes more sense. So sorry. So this is issuing the token. So what it does, it creates a method with callback, and also what it does, it just creates a transaction and sends it to self. Basically, yeah, you know what? I'm going to issue it in a fungible. This is the params. I'm not going to go into details about them. And as every call to the blockchain from inside the contract, you can provide the callback. And then in the callback, you can read the result of the previous transaction and continue your flow. So this one is issue callback. This is basically on the, well, we don't have this one, I need to copy it. So let's go here, cannot find. Also this one, that's strange. Issue callback. Yeah, because it doesn't understand the format. Okay, and this is a callback, and you have the callback, I don't know, in Java, that this seems like annotation. I don't know the name in Rust for them. Decorations, annotations. Might be a different name, I don't know. Payment token. So what this one does, it takes the result and it stores in the what's blockchain can call value payment to compare token ID set. All right, so it's basically this one is NFT token ID. This is part of the storage, so it sets the storage and also sets extra information. Sorry, this is the error. This is in case of an error. This is for the OK, and that's for the error. Let's not focus on the error. I'm sorry. So for the OK, and when transaction succeeds, you set the token ID in the storage, and for the error, just tries to output a useful error. And that's for setting the token. And let's do this one first, because that would be cool to greater. Sorry, cargo build. Now that we have this issue token endpoint, let's just call it. And for this, we need to build a script that actually calls that method, and it's here. Let's just copy it, and then we'll see if we need to copy some params. So for now, we deployed, and now we issue the token. So let's see what this one has in store for us. Actually, I have this one, gas limit, found that they're useful. And let's just make it easier to read. All right, so we have RPI contract call to that address using the alias address, the function issue token. For some reason, apparently, yeah, this is the mint cost, but I think it's the same issue token argument. All right, so this one actually needs more. Let's see, what are these arguments? Yes, there's a lot of things, because okay, so in order to understand these arguments, let's just go to our method of issue token. Issue token. So I'm just gonna put this one to the right, and I need to copy the arguments, and then I'm gonna go over them. Min cost val. You also need that one. Interactions. Let's add them here. And for confusion, just not to go. So what is happening here? This is the min cost. The min cost is all the time 0.05, but because Elrond denomination value is 10 to the power of like 18, you need to multiply this with this value in order to actually get it. So what I'm doing here, I'm passing this expression to this calculus method in order to get the result and assign this to the cost value, and then I am basically split, because this is more complex. You can do it in I don't know if this is gonna work, but let's try. Yeah, it does work. So basically we split by the dot. We don't need that. This provides us better precision. You only need the first part. Basically we need this one. This is equal with 0.5 Elrond this, but that's the value that we want. The token name is going to be a very simple token name, token 00next token, and also we need this one to convert it to hex. This is what this one does. This is just for me only in order to validate so now if we say echo, sorry, the reverse, I should get the same value, not like that. So no. Okay, so that it works. So just for you, so if we actually, so we need the hex value, and the ticker is actually the name that is gonna, the short name, and the Elrond blockchain is gonna add here at the end a random number to make it unique. And these are our arguments, basically the token name and the token ticker, this one and this one. This is what we need. So going back here, yeah, that's the value, that's the main cost and arguments. And then we also need, we're gonna use the proxy, the devnet, and the chain ID, and we're gonna say send. And the output, we're gonna be able to see how the actual transaction the signed transaction looks like in this folder. So let's go and see if it's gonna work. Interactions, so we're loading the methods. We need to deploy the contract again. Actually, we do have a contract deployed, but it's better to deploy this one because it has the new code for actually meeting the token. The other one doesn't have it. So we start from the beginning with the deploy. We deploy. It looks like it's deployed successfully, I hope. Let's go there and see. Too much gas provided. Gas needed was this. So let's just also fix this. I guess we can be like a 3-0 instead of deploy gas. Why is that? I think our contract is going to get bigger and bigger and bigger. Let's just address this one later on. So because probably we're going to end up needing more than gas. So we're not going to worry about this gas because it is success and we have the code attached, and that's the response we get. So now let's see what this one is going to work. Like issue token. Issue token. All right. So we have our transaction. So contract clean. Sorry. Project cleaned and apply contract build. Just build it again. We do have our scripts now already loaded. Deploy. Well, apparently not. We need to load them again because interactions. All right. Now here we are. We deployed. Let's just wait and check that everything is in order. It's a success, and we have also had the OK. And now issue token. Fingers crossed this time. All right, this is our transaction and it says success, issue token, and issue non-fungible. And we need to also, the response needs to be here somewhere. Just wait for it until it comes, because we're gonna, and that's the risk. This is the name of our token. We can decode it. How we decode, that is very useful. The reverse here, it's a nice neat trick that I use to read values from contracts. So let's just check the name of our token. That's our token. This is the ticker, and that's the unique number that you get from the blockchain assigned to this token. So now that's all good. We did what? We deployed, and we issue the token. The next thing we need to add the create NFT permissions rights. This one, create NFT role. It actually depends who calls this one. The create NFT, not assign roles. I think it's yeah, it's not here. We don't have it in this project. It's in the other one. We can drop split screen for now. So set local roles. Sorry, set local roles. So we also need to do this. What? No. I don't want that one in. Oh yeah, I do want it. Sorry. Yeah, that's good. So we added the interactions for the issue token, and also let's just add the interactions for setting the roles. So only the owner call this one, and the endpoint set roles, and it's again a self transaction, but says like okay, the NFT create. You're allowed to create NFTs. All right, go at the end. Async callback. I think that's it. There's no need for extra things. We just give permissions. We don't need to do all other things here. This should work. All right, so we do have this. So how do we interact with this method in our interactions? Well, I'm not gonna try to debug myself in because I already did that, and it's no fun. All right, so the set local role, this is our method to actually in our interactions we have set local, and see what we have here. We have the address. We're still using alias. Apparently, probably we're gonna need to change this, but who knows. Set local roles. That's the proxy chain. We're calling this method, and the output we added here to the local roles. And let's just see. We just compiled it. We need to load the interactions. And now we should have on our path set local roles, and we do. And let's see how this one behaves. Ending. That's our method, set local roles. Invalid function not found. Well, yeah, we also need to deploy the contract again and go from the top to bottom. So deploy. So we got deployed. We need to issue token now. Let's see. If we created this too fast, okay, actually the issue token was a success, but we need to wait the confirmation of the token name. Oh, come on. All right, that's we got the token name here. Honestly, I don't care how much the name the moment, and also set local roles. And let's look at this one. Success. local roles. Good. And of course the return, that's it, that's just okay from the callback. And now, ladies and gentlemen, we can actually call the method of like minting the NFTs. So hold on, let's just do a commit here. Come on, what do you want? Analyze code, check to dos. You really, I'm okay reformat, and I don't want to rearrange. So let's try again. Yeah, that's good. Yeah. And now, because we have deployed, we have issued the token, we have set the local roles, we're in good shape to actually like create the NFT. And going back to our method, create NFT. Basically, let's see what we need. We save big unit, royalties, manage buffer, big unit, and token identifier, and also the nonce. So the only thing that we do matter, because these are being provided auto wire by the interface using the var args here. The only thing that we need to assign is just the royalties, the URI, and the selling price, and also the name. This is what we need to provide. And trusty create NFT. This is what we need. Sorry. Create the NFT. Well, this one, as you see, we have the NFT name in hex, royalties, because Elrond can convert numbers to hex. We use them as is. Then the NFT URL, we convert it also to hex, and this one is hex fix, because God knows there's a bug. I'm gonna show it to you in a second, so you don't you understand why this one is called fix. And also the selling price, standard one. And let me show you this, what I mean. So create NFT. I'm sorry, I need to load these interactions. Alright, so now because they are loaded, I can show you what I mean. This is the NFT name. So let's do echo in. Sorry, I need to also allow. I think this is better. Alright. It's this thing that's an issue. The NFT is supposed to be the URL supposed to be this, but for some reason it adds a space in this value, and I don't know where it comes in, and that's where the fix comes in place. Because if I say echo my fix, this is only this part of the URL without this entry point. So I just don't know from where that one comes, and somebody like a bash wizard is able to point me out to why I get this at the end. It's fine. And I struggled for this for literally a day, bugging everybody from the Elrond developers channel on Telegram, which, by the way, you should subscribe and be an active member there. And nobody was able to help me. But what I did is just split by space and get the first part of it, because that's what I need. and add it to my params. So the actual parameters here, the usual stuff, calling the contract, that contract address using the contract address, using alias, that's the small gas limit function, create NFT with our arguments, name, royalties, URL, and also selling price. And then the chain stuff, proxy, chain ID, and the logs, they go there. And let's see, create NFT. And boom, fingers crossed. Let's see if it worked. Success, create NFT. And the arguments, they look good. And it says 111, and let's just also look at the callbacks if they're done. Well, actually, I think that's it. If we go at the contract, we can look at the NFT part, and we see that's our first NFT that got created. I'm sorry that I didn't show you before during this, but I guess we're gonna be able to do that. And next, it will be the buying the NFT. But let's do a commit here, because this is cool already. So let create NFT interaction. And the next one would be buy NFT. So let's go to the models. And this is a payable, Enterprise by NFT. It's a little bit more evolved. You can also pass the token that you want to use to buy. And our contract is pretty small. It checks if you're using the right. Well, that's it. No dependencies of anything. Required token issued. And then it sends to the owner the money that it gets in. So there are two things. It checks that the token, so required the price tag is the one provided, and also payment nonce is the correct. Basically, it also checks the required amount is the one that is stored in the storage. And then, okay, everything is sent. It sends the NFT, and then it sends the money to the owner, which is nice. Well, that's pretty much it. And the interactions for actually like calling this method by NFT. Right, by NFT. As you see, the selling price is set to 7 in our, so we need to set the same one, and this is the actual NFT that we're gonna call to actually buy. But all of this will need to be redeployed, rebuild. Actually we added our buy NFT. I guess it would be nice also to add our tests. Let's copy the mandos test before we go about doing anything else. This is buy NFT. Oh, not like this, but like this. Yes, I want this one file there. So this is relying on the steps from the second step, second set of scenarios, which one depends on the first set. It says the buyer with the balance, so it has enough money to buy, and then it does some tests to check for like buying the wrong stuff, checking the accuracy and like how solid is your contract of not being so first test, one failed, function not value, invalid function, so load, and let's do all tests again. Okay, all tests succeed. They also have the interactions, and let's go and load them, and now we need to deploy again, and from the beginning. So all right, we have deploy. Good. We have issue token. This one we need to watch until it's until it's finished, and we have the token name. Oh, come on, give me the token name. Yeah, finally. Yep, it's this one. And now we set the roles, which this one is succeeded. And finally, let's create a couple of NFTs. Create. Again, I created one too fast. Let's go to the contract. We're gonna have one NFT. Oh, actually, no, we got lucky. Cool. Come on, show me the NFT. Maybe something wrong with the transaction. Let's just look at the transaction. Failed. Role not set. Cool. Set roles. Forgot about this. Set the roles. Pending. Success. We do have the roles. So now, if we go to the contract, there are no NFTs here. And let's create the NFT. Success. So one NFT. Let's just create a bunch of them. 2, 3, 4. So we should have 4 NFTs. 2, 3, probably also. I don't know. It's gonna pop up also the other one. Last one. And now let's go and load dev wallet on DevNet. Let me access my testnet wallet. And let's go here at the NFTs. As you see, this one is the from my research, but you'll see that we will have like a different test 01 NFT pop up here after when buying it, because in our create NFT, in our buy NFT, we're using the Bogdan wallet, which I also opened it here. And let's buy the first one from the contract, and fingers crossed it goes well. Buying. Come on, let me buy this NFT. Let me buy this NFT. Pending. It's not good. Whenever it stays so long, something's wrong. I guess we'll find out. You know what? Actually, this time was good. So we successfully bought the NFT. So now if we go to our wallet and refresh, come on, NFTs. All right, we have it. And there you go. Which one is it? So this is F0, F0. It's this one that we bought, the 001. Let's just buy the 002, the nonce, because it's still there. We just need to load the interactions, and now this is gonna buy 002. Oh, come on. And success. Also, I bought the second one. Now in the wallet here, we're gonna have, all right, it was refreshed. So we have from the same collection of 00, whatever this one is, 25, we should have 2 items. Let's refresh. Oh, next. And there you go. Well, actually it has to be on the previous one. Oh yeah, it's here. I didn't notice. So this is the first one and the second one, and that's it. The only thing that left to do is a commit. We have what version file? Yeah, and also the NFT. So boy NFT and git push. Check out main. I'm gonna copy this one into main. And that's it. I hope you had fun, and if you ever wondered how you create NFTs on the Elrond, I hope this answered most of your questions. So have fun, and see you all next time. So that's it. I hope you had fun creating, buying, and selling NFTs, and please don't forget to like, subscribe, and see you all next time.